Alright guys, so today what we're going to look at doing is lesson 3 in geometrical transformations, more specifically composite transformations. We've already looked at rigid transformations in lesson 1. That consisted of translations, reflections, and rotations. Lesson 2, we looked at non-rigid transformations, specifically dilations. Today we're going to do a mix of all of these kind of put together in composite transformations. Now, if we start on page 9, we're going to first of all create a brace map for composite transformations. This is going to help us make a definition of what we're actually trying to do. So if we think of the two things or the two words in composite transformations, we have our first word is composite. And our second word is transformations. Now, everybody should know what transformations is, especially from lesson 1 to lesson 2, and in previous units where we actually transform functions. Again, transformation still means the same thing, which is just to move an object. Okay, an object can be a function, a point, a line, or figures, and what we're going to focus on are points and figures. Now, composite, some of y'all say, well, Mr. Hare, I don't know what that is. Yes, you do. When we looked at factoring, we looked at composite numbers. So if you think for a couple seconds about what composite numbers are versus prime numbers, some of y'all have family members that work in trade fields that work with composite material. Composite or compost is just a whole bunch of stuff put together. Another way you can shorten up a whole bunch of stuff is just multiple. Okay, so composite just means made up of multiple. Okay, so if I want to make a definition of what composite transformations are, it's just multiple movements. Okay, now don't overcomplicate this. For actually completing these problems, I'm actually gonna go through a flow map to help y'all, and it's very simple. You still want to, first thing again, is I pick one point. Okay, it doesn't matter A, B, C, D, E, F, G. Just pick one. Again, before we left, we looked at moving a whole bunch of different figures, and the more stuff you do, the more likely you are to get it wrong. So if I can only focus on one point, I'm going to do everything the problem wants me to do, go to my answer choices, I'm going to check it. After I check it, if I don't have my answer, but I've been able to mark off one or two, now I can go back and I can pick a second point, maybe a third if needed. Most of the time, again, if you can get through one or 2 points, you'll get your answer. Okay, so after you pick your first point, the second thing you're going to do is you're actually going to start transforming it. Okay, so I would say complete or perform desired transformations from left to right. Now, it doesn't matter if it wants you to do 1, 2, 3, 4, 5, 6 different transformations. Just do them in the order you see them from left to right. This is actually really good practice on going back and reviewing translations, reflections, rotations, as well as dilations, because everything is fair game at this point in time. Again, you're just doing multiple transformations. All right. Big thing here is that order matters. Okay, if you don't remember anything else, order matters. What this means is if you have transformations or a composite transformation and you are asked to do a translation first, then a reflection. If you don't do translation, then reflection, you're going to get it wrong. So, I know some of y'all are more comfortable doing translations. Some of y'all are really good at doing reflections. And rotations, we're okay with. But if I had to ask y'all would definitely choose reflections and translations over rotations. Above those two, I think y'all actually choose dilations. So we can't necessarily go with what we're most comfortable with. We have to go from left to right in desired transformations. We'll actually work on a couple of problems on page 10. Alright, so on page 10, starting off, I want to translate triangle ALT if A is at -5, -1, L at -3, -2, T is at -3, 2, by the rule of the original point XY changes to x plus 6, y minus 3, then reflect that over the y-axis. Alright, so again, if I go back and I reference my flow map, first thing I want to do is pick one point. My strategy personally for picking one point is pick the point that's the closest to the origin or has got the smallest numbers. The reason I do that because, again, the further I get from 0, the more likely I could miss a box or miscount. So if I look at this, I'm probably going to start with T. So T at -3, so -1, -2, -3, and then up to, I get right here. So this is where T starts, at -3, 2. Now I want to apply the rule. So -3, 2 is my original. I need to do x plus 6 and then y minus 3. That's going to give me -3 plus 6 and then 2 minus 3. So all I do here is plug in the values of my original T. Okay, so -3 plus 6 is 3. 2 minus 3 is -1. This is equal to T prime, or the image of T. So 3, -1. Now, once I do this, I want to reflect the image over the y-axis. So the y-axis, XY, I want to reflect it over this y-axis. Now remember, with reflections, you must be the same distance from your image to your pre-image, or pre-image to image, however you're going. This one, if I count to the line, I go 1, 2, 3. I'm 3 right from my line, so now I just need to go 3 left. 1, 2, 3. It's going to be T double prime, and then I count this, or I plot this, and it becomes -3, -1. All right. So, and you repeat that process for points A, L, and T. what I want y'all to go ahead and do is try to do point L, or we'll call this a we do, and then y'all do A afterwards. So again, starting with L, think about what your first step is going to be. First step will be you plot it. So -3, -2 is L. Then the second thing we do becomes 3, -5, and this is L prime. Then we perform our last transformation. Again, reflect over y-axis. So again, I'm 3 to the right. I go 3 to the left. And then now y'all find the end point, or the double image A. All right, so we're going to see if you got it right. If you got it right, you're going to see the results via the play posit. If you got it wrong, see if you can find out where you messed up at. Okay, so -5, -1 is A. So again, plot my original, do the rule, or I write the rule it wants me to do. After I do the rule, I'm going to actually apply it. Again, whenever I plug stuff in, I put it in parentheses, and that's just a habit I got from doing substitution or plugging things in so many times when I was in college. It's just second nature to me now. So -5 plus 6 is +1. -1 minus 3 is -4. A bunch of y'all probably messed up here, if I'm guessing, and got 2 or -2. If you did, you messed up on signs. Okay, that's what makes these hard as translations, is that there's adding and subtracting, and sometimes we have to, subtract negatives. After I get my original point, or my image, become 1, -4. After I got 1, -4, that was probably an answer choice. Don't choose it, okay? Test makers are going to know that students are not going to perform the entire composite transformation. They're so used to seeing, oh, just do one transformation and go find your answer. All right, so 1, -4 is A prime, and then reflect across y-axis wound up being here, and this is A double prime, which completes the composite transformation, and that was your answer for A, -1, -4. And excuse me, I forgot to put L up there, and it was -3, -2. Okay, so these aren't terrible. So we'll do B. I'm going to do 1 this time, and I'm going to go a little bit quicker through it. Just, focus on what I'm doing. You can pause the video right now and see if you actually get the answer correct before I get to the end, just to get you some extra practice. So I'm going to start off with A because it's the closest to the origin. at 1, 1. First thing I want to do is reflect over the x-axis. So here goes my x-axis. I'm going to reflect over it. I'm up 1 from it, so now I need to go down 1. I'm going to plot this. So it is 1, negative 1. And then I'm going to reflect it over the y-axis. So now I'm going to go reflect over the y-axis. After I reflect over the y-axis, I finish here. And this is negative 1, negative 1. And that would have been my answer. Okay. Now, y'all do T. After you plot, so again, we picked a pointer this time. I told you to do T. So first thing is plot the original, or plot your pre-image at 2, 3. Reflect over the X, so I'm up 3. Now I need to go down 3. 1, 2, 3. That's going to be my T prime, or my image. Now I need to reflect over Y. 2 right, so I go directly to left. This is T double image, or double prime, and then you plot it. So negative 3, negative 2, and the first one, or your image, was 2, negative 3. I forgot to write it, I'm sorry. Then C. Again, I'll do 1, then y'all do 1. Again, I pick ones that are closest to the origin. L and T. I'm going to choose L. Again, what is the first thing I do? I plot my point I'm working with. Okay, so negative 3, negative 2 is L. I want to rotate it 90 degrees clockwise. So 90 degrees clockwise just tells me I'm going that way. Okay, so this is the trick we learned before y'all left. If I want to rotate it 90 degrees clockwise about the origin, I'm going to have my paper standing straight up and rotate it 90 degrees. So this arrow is going to come here, or I'm going to give it a 90-degree turn. Once I give it a 90-degree turn, I'm going to plot this ignoring my signs. This is where knowing the coordinate plane, that on the left side, X is negative, top Y is positive, bottom Y is negative, right side X is positive. So if I plot this, I get negative 1, negative 2, 3. Again, I don't use rules because I'm not smart enough to use them. It's more stuff to remember, so like I try and keep everything extremely simple. Now, reflect over the line Y equals X. So I actually draw this line. If you don't know how to draw this line, don't be scared to do this right here. Y'all have Desmos. Y equals X. It's actually going to pop it up, okay? And that'll help you plot your line. After you plot your line, if I look, I'm kind of like, you know, I'm right here. I'm kind of either to the left or up 1. So I can see that mirror. Also, if I fold this paper along this crease, these dots are going to line up. Okay, mirror images, the same distance. When I plot this, it becomes negative 2, negative 3. Don't mess up like I did. I just realized I messed up there. All right, now because I messed that up, I'll let y'all do T. Again, the first thing you should do is plot your point. So -3, 2. Second thing you do is figure out the first transformation they want you to do. They want y'all to rotate 90 degrees clockwise. So start here, rotate 90 degrees, plot, or now find this point ignoring the numbers. So over 2, up 3. And now reflect this across the line y equals x. So how can I get to this line? I can go down 2, right 3. Okay. Or you can take your time, fold along the crease line. And this is my suggestion. The day of y'all's final exam, I do this right here every time. Because if you don't remember the rule, no harm, no foul. Again, see how I'm folding along the crease line? And then you just take your pencil, take your pen, and you push down really, really hard. Or in this case, so I can be a little bit more accurate, I'm just going to poke a hole in the paper, pick the paper up, where this hole is, right there, that's my new point. This always, always, always works. I just made a mistake because I got too happy. See, after I plotted my first point, I didn't plot my image after I rotated it. So slow down, don't make that mistake. That's also another very, very common mistake, is people not taking the time to slow down and plot their second point. So when I plot my second point, I'm going to say that this is wrong. I'm actually going to mark it with an error. So my second point was 2, 3. And now, again, I can do the same thing. I can crease it along my line. From here, I can just poke a hole. And then, boom, I get my answer all the time. And it becomes 3, 2.